Hi everyone, we're back with Chapter 4, Insolation and Energy Balance. In Chapter 2, you learn about the seasons and the uneven distribution of solar radiation during the year at the top of the atmosphere, as I know, the solar constant. Then, you learn about the atmospheric composition in Chapter 3. Now you're gonna learn how solar energy passes through the atmosphere and how the Earth's surface budget is energy. Today's learning goals are: understand the solar energy path and its way through the atmosphere to Earth's surface, the concept albedo, understanding how energy is transferred by radiation, conduction, convection, and advection. Understand the role of greenhouse gases in the atmospheric heating and cooling. Identify and compare energy, heat, and temperature. Explain the global pattern of solar radiation, sensible heat, and latent heat. Most of us use the word heat to mean something that feels warm, but science defines heat as the flow of energy from a warm object to a cooler object. Actually, heat energy is all around us, in volcanoes, in icebergs, in your body. All matter contains heat energy. So heat energy is the result of the movement of those tiny particles called atoms, molecules, or ions in solids, liquids, and gases. Heat energy can be transferred from one object to another. The transfer is flow due to the difference in temperature between the two objects is called heat. For example, an ice cube has heat energy, and so does a glass of lemonade. If you put the ice in the lemonade which is warmer will transfer some of this heat energy to the ice. In other words, it will heat up the ice. Eventually, the ice will melt and the lemonade and water from the ice will be at the same temperature. This is known as reaching a state of thermal equilibrium. Matter is all around you. It's everything in the universe. Matter is all around you, is everything in the universe. Everything that has both mass and volume and takes up the space is matter. Matter exists in different physical forms: solid, liquids, and gases. All matter is made of those tiny particles called, remember, atoms, molecules, and ions? These tiny particles are also always in motion, either bumping each other or vibrate back and forth. It's the motion of the particle that creates the form of energy called heat, or thermal energy, that is present in all matters. The particles in solids are tight packed and can only vibrate. Then the particles in liquid also vibrate, but also they are moved around by rolling over each other or sliding around. In gases, the particles move freely with rapid random motion. At high temperatures, particles have more energy. Some of this energy can be transmitted to other particles that are the lower temperature. For example, in the gas state, when the fast-moving particle collides with a slower-moving particle, it transfers some of this energy to the faster one to the slower one, increasing the speed of that particle. Particles colliding each other, an area with high energy will slow transfer across the material until thermal equilibrium is reached. The temperature is the same across the material. All heat energy, including heat generated by fire, is transferred in different ways. First, convection transfers heat energy through gases and liquids. As the air is heated, the particles gain heat energy, allowing them to move faster and further apart, carrying the heat energy with them. Warm air is less dense than cold air and will rise. Cooler air moves in below to replace the air that has risen. It heats up, rises, and is again replaced by cool air, creating a circular flow called convection current. This current circulates and heats the room. Very similar you have in your convection oven and your refrigerator. Think about. Conduction transfer heat energy in solids. The moving particles of warm soil material can increase the heat energy of the particles in a cooler solid material by transferring it directly from one particle to the next. Since particles are close together, solids conduct heat better than liquids and gases. Radiation is a method of heat transfer that does not require particles to carry the heat energy. Instead, heat is transferred in infrared waves, part of the electromagnetic spectrum. Heat waves radiate out from hot objects in all directions, traveling at the speed of the light, until they hit another object. When it happens, the heat energy carried by the waves can be either absorbed or reflect. Fire illustrates the three different methods of heat transfer. For example, the firebox will heat up due to convection. The air above the fire will be warm due to convection. You can warm your hands near the flames. The climate system begins with energy from the sun. At Earth's distance from the sun, the light has the intensity of 1,370 watts per square meters. This value is sometimes called the solar constant, although it does change over time. The Earth is so far away from the sun that the incoming rays of energy are all essentially parallel. So the sunlight strikes the planet perpendicular to the surface near the equator, but it strikes in the oblique angle near the poles. This means that insolation is more concentrated near the equator and weaker near the poles. In other words, the heat flux density, watts per square meter, is greater at the equator than the poles, so the energy will be transferred from the equator, who receive 2.5 more energy than the poles, towards the equator. Think about who transferred this energy. Air, you have global circulation, and also you have the ocean currents to help to transfer the energy. As sunlight passes through the atmosphere, some of it is absorbed, scattered, and reflected by air molecules, water vapor, clouds, dust, pollutants, forest fires, and volcanoes. This is called diffuse solar radiation. The solar radiation that reaches the Earth's surface without being diffuse is called direct beam solar radiation. The sum of the diffuse and direct solar radiation is called global solar radiation. Atmospheric conditions can reduce direct beam radiation by 10% on clear, dry days and by up to 100% during thick, cloudy days. Albedo is another one, is the amount of the solar radiation that is reflected by some surface and is often expressed as a percentage or as a decimal value. Overall, albedo is a measure of the reflectivity of the surface of the Earth. White objects, such as a snow hill, have a high albedo. Conversely, dark objects, like pavements, have a low albedo. Because of this, part of the energy-efficient building design is taken into consideration wherever a wall or ceiling warms the building or keeps it cold, resulting in the choice of dark or light coating respectively. The albedo on Earth can vary slightly. Changes in albedo occur as a result of varying degrees of cloudiness as well as the amount of cloud cover, snow, ice, and vegetation that exist in a given area. Since it is one of the major properties that controls how much energy reaches the surface of the Earth, it's an important factor in climate models. In addition to describing the property of an object such as its color, the albedo can provide information about the land's surface, including soil moisture, amount of vegetation, and levels of urbanization.